Calibration of disc probes. One of the unusual probe buildups that you may wish to use for measuring things like O-ring grooves in deep bores is a disc probe. And the only way we can calibrate this disc probe is by using a partial section of our calibration artifact. And in order for that to be possible, we've had to previously locate this calibration artifact using a normal spherical stylus. So let's have a look at this. So I've got my probe utilities window open, and I've got the beginnings of a probe buildup for this disc probe, all the way down to the TP2. What I want to do next is between my disc probe and the body of the TP2, I want to ensure that I have a small amount of extension. Usually 10 millimeters shall do it. So we'll select that 10 millimeter extension. What you want to do next is take the disc stylus that you plan on using and just quickly have a look at it with a caliper so you can determine the diameter and its thickness, because that's how they're listed inside of the hardware description. So what you want to do next is scroll down through the list of the hardware until you find the disc that you're going to use. Now, my favorite disc is the 25 by 3 millimeter disc, because it's slightly larger in diameter than the body of the TP2. So this allows me to get fairly deep into bores and measure O-ring grooves and things like that. So the next thing we want to do is go into the probe measurement dialog, and we want to change a couple of the parameters to suit this sphere. First thing we're going to change, number of hits. We'll put that at 15. And down here under calibration mode, I've toggled it to user defined, 3 levels, which will be 15 divided by 3, 5 hits per level. And here's the trick right here. Start angle is -7 degrees, end angle is +7 degrees. And then down here I've chosen my green sphere, which I've previously located with my normal spherical stylus. So the software can automatically go and measure this sphere without having to try to do any locating hits. The next thing you want to do is make sure that this is on DCC and not DCC plus DCC or any of the other ones. We want it to go straight to the sphere and do those 15 hits. So if we hit measure now, it's going to go ahead and calibrate our disc probe. Now, when you're presented with a dialog that says, has the qualification tool been moved or the CMM 0 point changed, you are now going to select no, because we have previously located this calibration artifact. And finally, the last thing that we want to do is to ensure that we review the results of our calibration. We're going to look at the size and the standard deviation. The size is most important. Depending on the size of the disc that you choose, you may have to reduce or increase the probing angle in order to get good results. So we want to make sure this size is around nominal. If it's not, then try reducing the probing angle from ±7.5 degrees down to, say, ±5 degrees. And we would do that for thinner discs. Or you could increase the probing angle from ±7 degrees up to ±10 degrees for thicker discs. So you need to review these results carefully. This is what it looks like when the disc probe is calibrating at the ±7.5 degrees. You'll notice that we don't take any hits on top of the calibration artifact. Calibrating a star cluster in PCDMIS. A star cluster is a very useful probe configuration for measuring features on your part that you would not be able to measure otherwise using a normal probe setup. Let's look inside of PCDMIS on how to build and calibrate a star cluster. So inside of our probe utilities window, you'll notice that I've built a normal configuration